So today our objective is to understand what vectors are, and to learn how to do math with them. Okay, so we're going to talk about it. It's, again, most people have never seen this before. There's strange little symbols and things that look familiar, but they mean something different than what you're used to. We do have vocabulary in this one. I don't think we have any. Yeah, we don't. We have lots of vocabulary, and we have no theorems or postulates. Actually, we're all done with postulates. I forgot about that. So sad. No more postulates. All right, so let's start with what the heck is a vector? Anybody ever see, it's an old movie now, it's a comedy, and it's really, some of it is just darn right crude, but it is actually kind of funny in a lot of parts, called Airplane. Okay, you guys remember that? Well, there's a scene when they're in the cockpit, and they're like, "What are your vectors, Victor?" And I always remember that, because it was just such a funny line, but he was asking, where are you located? But in aviation speak. Okay, so what is a vector? A vector is any quantity such as a force, velocity, or acceleration. So you also hear this in physics class. That has magnitude, probably not at junior high level, but you never know with the new state standards, which deals with size and direction. So a vector explains a direction, and it also explains how large something is, so how distant something is, okay? So vector is written this way. It's described by 2 points, so a starting and kind of an ending point. And there is it's an arrow with only half of the arrow showing. So it's flat on the top, and it's got the half of the arrow above it, okay? That's read as vector AB. Okay? Now, this vector is written, though, as an ordered pair. Now, if it's written as an ordered pair, and it's supposed to be telling me directions, what's really happening in that ordered pair? Is it just a number, like I'm here? Okay. So we've got some movement in a direction. So we have a starting point and we have an ending point. So what is this starting to trigger in your mind that we've been learning about in this chapter or in previous chapters? What did you say, Troy? You mouthed something. Nobody? It is the distance formula, but which relates back to the Pythagorean theorem. So basically, here's a situation. Let me draw you a picture of vector AB. Okay, here's vector AB. And the vector written as an ordered pair is telling me directions, how to get from A to B. So what it's saying is not it's at 4, 3. It's saying you need to go for the x direction. You need to go 3 the y direction, to get to B from A. So it isn't just here's where I'm at, it's telling me distances I have to travel to get where I want to go, okay? Which is Pythagorean theorem. So this 4 is the change in x. How far x do I have to travel? And then change in y. How far up do I need to go from that new x point to get to my new location of B? Okay. So, again, written as an ordered pair, but the ordered pair is not a location itself, it's directions to get to the new location. So it's basically giving you distance formula or Pythagorean theorem, which comes from, distance formula comes from Pythagorean theorem. Okay. So that's what's kind of interesting about a vector. It doesn't tell you where you are, it tells you how to get to where you need to go. Okay? So let's talk about magnitude. I mentioned that word. And what did I say magnitude meant? Size. So magnitude wants to know the size from A to B. Okay? Which, if you picture back here, what position does AB play, vector AB play, in the little drawing that I had? It plays the role of the hypotenuse, right? So that is our distance formula. Now, based on the numbers I have, what would you say the magnitude of this particular vector is?
5.
It would be 5, right? Because we had a Pythagorean triple, 3, 4, 5. Okay, so magnitude is the length of the arrow formed by the vector. Now, to show magnitude, they do it this way. They take the vector and then they put it in absolute value signs. Because remember, we're trying to figure out how long something is. It always has to be positive. Okay? It's always going to be positive. So we're going to use Pythagorean theorem or the distance formula to calculate the magnitude. Okay, so let's do an, oops, wrong direction. Let's do an example of this. So I'm going to be giving you, oops, change my color, some information. So what I'm going to be given to you is that you have 2 points. We have P that's located at negative 5, 4. And we've got Q, oops, and Q that's located at 1, 2. And I want you to give me 3 things. A, I want you to sketch the vector. So sketch vector PQ. B, I want you to find, oops, PQ. Now when I ask you to find the vector, I'm asking you to tell me the directions to get from P to Q. The letters are written in a specific order. P's your starting point, Q's your ending point, okay? Last, I want you to find the magnitude of vector PQ, okay? So we're going to sketch it. We're going to actually figure out the directions to get from P to Q, and then we're going to figure out how long vector PQ is. So to sketch it means we have to graph. So you guys might want to use some graph paper tonight. Let's see, negative 5, 4, and then 2. So here's X, here's Y, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I'm going to graph P is at negative 5, 4. So here's my P. Q is at 1, 2. And what I do is oops, that's a terrible line. I start at P and my arrow is at Q. Okay? So that's part A, done. Okay? To find the second piece, which is actual, how do you get from P to Q? What we're going to do is we're going to take, and this is the weird part, because I'm trying to figure out the distance, I'm going to go to where I end and subtract where I began. Okay? I could count it if I wanted to, but mathematically I'm going to start where I finish and I'm going to subtract where I began. So end minus beginning. That's how we're going to do the math. So we're going to take our coordinates for our x's. So I have 1 take away negative 5. That's my x value. And then for my y value, I'm going to have 2 take away my 4. So I have 1 take away negative 5 is 1 plus 5, which gives me a 6. And then I have a 2 take away 4 is a negative 2. Okay? So again, from here to here is 6. And from here to here is negative 2. Now, somebody, hey, there he is. Somebody, I figured so much. Somebody had mentioned slope, and actually that person was on to a really smart idea, because slope is the change in x and the change in y, but it's written as a fraction where the change in y is on top and the change in x is on the bottom. And so you can take your vector and you can write it as a slope. And if you notice, what kind of slope will you get from this vector? You're going to get a negative slope, right? Which goes along with the picture that our line is going in the negative direction. So it kind of helps you keep things together. So that is my vector. So we go from the end and take away the beginning. That's how we figure out a distance. Okay? Part C says now figure out the magnitude. Well, remember what we said. We can use Pythagorean theorem. We could use the distance formula. I'm going to show it with the distance formula for the magnitude. So we're vector PQ. And it's going to be the square root of the difference in the x's, which is the 6, that squared, plus the difference in the y's, that's that negative 2 squared. Okay? And then we just do math. So we get 6 squared is 36, negative 2 squared. Boy, we've seen this answer. That was the other problem, right? And we get the square root of 40, which simplifies down to 2 radical 10. And that's your final answer. Okay? So that's some of what you get to do tonight. And that the hardest part is remembering end minus beginning. That's how we figure out our lengths. Okay? Sometimes we get positive, sometimes we get negative. But if you're looking at the way that your vector's written, look at the slope. If the slope is a negative slope, you're going to have 1 positive, 1 negative. If your slope is a positive slope, you're either going to have 2 negatives or you're going to have 2 positives. Okay? So that's another thing to watch out for. Okay. I'm seeing some kind of blank stares. We okay? Now we get into other things. So another vocab word. This is called a scalar multiple. And a scalar multiple is simply a multiple of a vector. It's kind of like how we could have a multiple of a Pythagorean triple. Because remember, Pythagorean triples are representing lengths of sides of a right triangle. The two numbers that we have are basically the lengths of the sides of the right triangle. And then the magnitude is us figuring out the hypotenuse. Okay? So we can have Pythagorean triples, a 3, 4, 5 can also be a 6, 8, 10. all I did was multiply each item by 2 to get to the next one. And it's the same sort of idea. So multiplying a vector by a real number multiplies the length by the absolute value of that number. And we'll demonstrate this. So what happens is we're going to multiply by the number, but we will have to contend with some signs, so we have to be careful. And here's kind of the key point with signs. Multiplying a vector by a negative value Now you think about it. We said we could take those vector numbers and we could write them as a slope. If I multiply a slope by a negative, what happens to your line? Depends on what you had to begin with. If you take a slope, let's say, of a half and you multiply it by -2, now you've got -1. So your slope went from being positive to a slope that's being negative. So if you're drawing that, you've got a slope that's positive, now it becomes a slope that's negative. So you're actually changing the direction of your vector if you multiply by a negative. So multiplying a vector by a negative value changes the direction of the vector. So just as a demonstration point with this, if I have vector PQ and its value is AB, so it takes an A across the x-axis, an A move, from there a B move to find out where Q is. If I multiply that vector by K, and you will not see the parentheses, I'm just telling you that right now. They'll just stick the number right in front of it with no parentheses whatsoever. What that's telling you to do is to take each of those values and multiply it by K. So something that had a value of 1 and 2 now becomes, and let's say K is 3, now becomes 3 and 6. So we've made it longer. We've tripled it in size, okay? All right, we've got another vocab word, perpendicular vectors. So these are two vectors where the arrows representing them are perpendicular to each other. And then again, remember, the slopes are opposite reciprocals. Okay. All right, I got two more vocab words and then we'll do an example. Let's see, let's go. Parallel vectors. Those are two vectors where the arrows representing them have the same direction. Or opposite directions. Not perpendicular, not at a right angle. They're either going, they can go really tip to tip, just like this. They can go like this. They can go like this. So it's not a traditional looking like they're parallel necessarily. So again, the good visual there on the pages in the book, in the lesson. And then last, we have what's called equal vectors. And equal vectors are two vectors that have the same magnitude, so same size. Magnitude. And same direction. Okay. Now remember, where do we hear that magnitude a lot? Earthquakes. And the magnitude of the earthquake is how big, the size of that earthquake. So it has that same sort of meaning. Okay, and so again, vectors represent slopes, and those slopes can indicate parallel or perpendicular. So if I have vector PQ and it is AB, remember A is the difference in the x's, B is the difference in the y's. That's how we can write the slope. Can be used with those vector values because they are showing exactly what the slope formula tells us, differences, okay? All right, everybody good? Do some examples real quick. So, A, show that 9, negative 6, and negative 6, 4 are parallel. So we want to, those are vectors, we want to show that they're parallel. Okay, so let's do that. So for the first one, it's negative 6 over 9, it's the y over the x. Simplify it down. They both have a 3 in common. We get negative 2 over 3. Second one, it's 4 over negative 6. Simplify it down, we get negative 2 over 3. Since the slopes are the same, and we know that parallel lines have the same slope, we can conclude, do you guys remember the 3 little dots mean therefore? Therefore, the vectors are parallel. Okay, it's as simple as that. Well, what if we want to say that show that these vectors, and we'll keep the 9, negative 6, but we're going to change the second vector to 2, 3, are perpendicular. So again, we do the slope. First one, negative 6 over 9, simplifies to negative 2 over 3. And then the second one, we have y's over x, we get 3 halves. So when I multiply negative 2/3 times 3 halves, I get negative 1. Therefore, the vectors are perpendicular. Last thing about vectors is you can actually add them. Vectors can be added. So what does that look like? So let's say we have one vector is AB, and we want to add that to another vector, let's call it CD. So when we add, we're going to add A and its corresponding value C, and we're going to add B and its corresponding value D. And that's that. Okay?